Hello guys, welcome to yet another tutorial video. So today we're going to take a look at a solution or the solution to our previous video where we posted the challenge or our first exercise with two challenges, the first and then the second, and I hope you guys, at least one person, would have been able to solve either one or both of these challenges. So the first one, I'm just gonna go ahead and start solving the first one. You write my algorithm, and then we'll see how that works out by testing it with some input and then see if we are getting a desired output. So basically, I will not go ahead and read the preamble again, so I will just move into the input. A three space, the first one says the first line containing three space integers a0, a1, a2, describing the respective values of the triplets a. So I'll just move into my code and then declare three variables right here. So int, I'll take a0, a1, and then a2 real quick, and then since the next one is also going to be added, b0, b1, and b2. So I have my 6 variables here. Now the first thing I want to do is prompt the user to enter something. I just want to start by taking in. I just enter 3 space integers for the first first line. Okay, then I'll take those 3 in a0, a1, and a2. Then I'll prompt for the second input, enter 3 spaced integers for the second line, and take that one to in b0, b1, and b2 respectively. So I've taken my inputs in here. Now with these conditionals, and we know how to use our if statement and then make condition or make decisions here. So I'll go back to the preamble and see what it says. So it says that my task is to find their comparison scores by comparing a0 with b0, a1 with b1, and a2 with b2. If a1 or if ai is greater than a1, then our a is greater than bi, then a1 is awarded a point, and then vice versa, the other something gets a point, and if it's equal, then neither gets a point. So I'll just go ahead and get me a counter, or I'll get myself a counter, a1 counter, and then something counter. So both of them, I'll initialize them to 0 here, just to be sure of the value that they contain. Now after doing that, I'll move down to this one, try to make some decisions here. So the first thing I want to do is check if a0 is less than a b0. Okay, if that is the case, it means that the b person from our condition, it says if ai is less than bi, then Samson is awarded a point. So it means the second person gets a point, which is our Samson counter here. So I'm going to increase Samson counter by 1. So Samson, so if a0 else, now I could use else and then I'll drop the next one, but that way it will include both the equals to and then those that are greater than. So I'll explicitly state that else if a0 is greater than b0, then in this case a1 counter should be increased by 1. Okay, Then I want all of these. I don't want it to terminate here. I want another if else statement to be executed. So I'll go down, and since if they are equal, nothing is done, no one gets a point. It's basically pointless to write it. If you write it, it doesn't change anything. You write else if it is equal, then nothing happens. So it's basically not too necessary to write it. So the next one, I'll check for the A1. So if A1 is less than B1, then I move in and say Samsung counter. So let me just grab this, increment that one as well. So here it will increase it again, else if, and then take advantage of my laziness, grab this and drop it. Yeah, I'll do that. Okay, so the next one, I'll take advantage of my laziness again and grab this whole block, drop this and just change this to A2 and B2, and then here A2 and B2. And before I run and get an error or incorrect results, let me just change this real quick. That's what you get when you grab your code and you drop it. So B1. So here we have our counters here. So we have if A naught is less than B naught, Samsung counter is awarded, meaning Samsung gets a point. If it's the other way around, Aaron gets a point. So we do that for all of them. And now we go down here and we will just output the Samsung, the output format. We need to look at that before dropping our output, which I'm going to just go in here. So where are you? Is it yes. So here the output format says print to space separated integers denoting the respective comparison scores earned by Aaron and Samson. So the first one is Aaron and the second one is Samson. So basically I will do just that. So see out Aaron counter, and then give it some beautiful space, and then Samson counter, and then I'll flash it. And let me just end the line. So end deal, that's it. So I will save my program and then execute. So this is it. It's working fine, but we don't know that yet. We can't really confirm it. So let me execute this and then see if that is okay. So let me go ahead and just execute this program. Oh, we have no errors. So it says enter 3 space integers for the first line. So I'll take 0. Let me take 2, 3, 4, 1. It says enter 3 space for the second line. So this one is 1. How about that? 1 1 1. So there it says 2 0, and we can understand this. This is the second input, which is Samson's own, and this is Aaron's own. So here we compared these two, Aaron 3 and 1, and we realized that 3 is greater, so 1 is awarded to our Aaron counter. Then when the next one, 4 is greater, so another one is added to Aaron counter. And then the last one, which is equal, and nothing happens. So that leaves us with 2 for Aaron and 0 for Samson. Let's run this program again, and then with different inputs this time. This time around, I'm going to 1 2 3. then 4 5 6, it says 0 3, and you can see that the Aaron one has not been able to beat the Samsung one in any way, so that gives us 0 3. So let's take in the inputs. Let's enter the input that is in the example and see the sample. So we have 5 6 7 and 3 6 10. 5 6 5 6 7 and 3 6 and 10. Good. So there we have 1 1, just as expected, and as the input or the output for our first preamble showed us. So this is my algorithm for the first one. For the first part, I'm going to just I'm going to let me comment this out. Let me comment this out. So I'll write the second part, the second solve the second problem here. So this whole thing, let me comment it out. So this is multi-line comment. Okay, comment this one out. So this whole line, all of this stuff is being commented out. So basically the first one has been executed, or he has finished. We finished solving our first problem. So let's go to the next one, the very second one, which is the place where you are supposed to think. Okay, so the kangaroo problem. Since there are 2 kangaroos on the next blah blah. Now we are trying to find a way of hopping 2 kangaroos through a series of steps, and then we check and see if they will ever meet. So if they will ever meet, take note of this very first constraint, which says that x1 is greater than or equals to 0, but then it's less than x2. Very important, very important. So we go ahead and then we say print yes if they can land on the same location at the same time, otherwise print no. Now for those who already understand programming and they've done looping, some of them might move into loops straight away, like maybe you start an infinite loop and try to test for all cases. But it might work for you, your algorithm might work for you, but the running time of your algorithm will be very bad, especially when you are testing it with very high input, or if the input size begins to grow. So what I'm going to do here is basically write an algorithm very swift and an easy one, just going through our logic. We take these numbers and we see whether they will ever meet. So the first thing I want to do is declare 4 variables here again. I will declare 4 variables. Let me go down here. So I will declare integer variables, 4 of them. So A, B, C, and D. So 4 variables A, B, C, D. Now I will just prompt the user to enter these for me. Please enter the start. Let me see, what's the problem. What did they say? It says what is it? Says this x starts allocation this and moves at the rate. Okay, so we can tell the person to do it, enter the start. Please enter the start location, start location and rate for both, or for the kangaroos. And then I'm going to just in this order, or in this. Okay, oh sorry, in this order. Oh, this is C++, sorry. So let me just make sure I drop this new line here. Then I'll drop my there. So it pushes this to the new line. In the form, so x1 v1 x2 v2. Good. And yeah, so we do this, we enter, this is the inputs we are entering, and I'll go inside there, bravely collect all of them inside a, you know what, let me just use their lesson so we understand. It just becomes conspicuous, like x1 v1, it's self-explanatory. x1 v1 x2 and v2, right? v2. Good. So here taking x1, then we receive v1, then we receive x2, then the next one v2. Good. And we've received our data, what we need to do our processing. The next thing we want to do is now think of what should be done, the logic. So here I'm going to comment out and then write some few stuff here to see what I would do. So basically it says that the start location, the first kangaroo is going to start from here and it's going to hop through this particular rate. The second kangaroo starts at this point and hops through this particular rate. Now, is there any chance of them meeting? Now remember from I told you to take note of this particular preamble right here. x1 is less than v2, x1 is less than x2. So if we start this case, if x1 is less than x2 and or let me put it this way, if x2 or x1 is greater than x2 and v1 is greater than v2, then that way there's no way they will ever meet, because we have two trailing. The same way, if you have x1 less than x2 and then v1 to less than v2, they will never be able to meet, because the hops will always be greater than there will always be a lapse between the two hops. So one will be leading and the other one will not be able to catch up, since everything of it is less than or lower than the other one. So that way, that's one of the conditions that was. So if we have x1 is greater, here we have it, the preamble here is supposed to be less than, okay, it's less than, x1 is less than. So in any case where x1 is greater than x2, so this is not going to happen. Okay, if x1 is greater than x2, then this is just print no, because it's not going to happen from our preamble there. So if x1 is then print no. Then we go down again and check if we take the difference. Okay, here as I said, if both of them are greater, if they are greater than the other one, both the x1 and the hop rates are greater than the other kangaroo, then there is no way they are going to meet. There has to be this mixed thing between them. So the next thing I want to do is check the difference. Okay, the difference between x2 and then x1, and then the difference between v2 and v1. If I'm able to take the let me see, if I'm able to take the difference, if I'm able to take the modulus of the difference between x2 and x1 against the v2 and the v1, then that way we are going to have to print a no, because that way it means that our v2 is greater than our v1, okay, and our x2 is also greater than our x1, as I said in the first one. So that way we also have to print another no. Okay, I don't know if you get me, so let me write this. If v2 or if let me x2 minus x1 has a mode, if we're able to find the modulus of that against v2 minus v1, okay, so if print no, so if this also happens, we are going to print no. If the difference between our x2 and then the position we are starting from, our second kangaroo is starting, and then this first kangaroo is starting, if the modulus of that against the difference between the velocities of the rates of hops, it's actually calculatable. That means that our difference here is not negative, and it's not also zero, meaning it's a positive number, then we are going to have to print no. So let's write this and see if it's actually true or it will work. Let me see. So we are going to check if x1 is greater than x2, x and let me hit an O, v2 is greater, should be greater than, okay, v2 is greater than or equals to, so we know that our very first one is supposed to be, so v2 is supposed to be greater, is it? Our x1 is supposed to be less than our x2. So if that's the case, if x1 is less than x2, then the v2 should be less than the v1, because x1 will be the v1 will have to be greater, so that we can find, we'll be able to, at least the hops will be able to increase and then catch up with the next one. So we're going to say if v2, if this is the case, or v2 is greater than or equals to v1, okay, or the modulus of x2 minus x1 mode v2 minus v1, then I'm going to see out the fat no, and then end line. If any of these is not violated, I should just tell them yes. Good, so this should work fine. Yeah, I think this should work. Let's see the logic. If our x1, which is supposed to be less than our x2, x1 which is supposed to be less than our x2, is greater than or equals to is greater than or equals to, okay, let me leave that. It's worth it. It's greater than or equals to x2, or v2 is greater than or equals to v1. So v2 shouldn't be greater than v1 since x2 must be greater than x1. So, or if the difference x2 is, we are able to take the mode of v2, so meaning here is this basically the same thing here, or maybe some of this some that same sort, because we're able to, if v2 is greater than v1, surely this will be able to find the modulus of this whole thing, which is actually this one. So we're just reinforcing several conditions here that evaluate it true. So let's run let's execute this program and see what we have. In that order, I'm going to, let's take the test case. They give us a test case, see if this works or not. The test case 0342 0342. Yes, so it says yes. Let me see what they have. Yes, they have yes. So after 4 hops, we're able to make this movement. Let me close this and then rerun it with something else. Let me see. 3 3. Okay, 3 3. The hop is 3 3, and then the next one 3 again, and then 2. It says no, so we are not able to. This one clearly stating, you realize that the first one, the kangaroo, starts at this and it hops through 3 steps, and then our second one also starts as 3, but then it hops through how many steps? 2. So they will never meet, there will always be a lapse. So this is my algorithm for solving this problem. If you find it or if you find any of these algorithms inappropriate or not optimal enough, you can challenge by writing your solution or your suggestions on to the comment section, and then we will have a discussion. So this is it. This is gonna be it for the solutions, and I hope next time I'll have more people. In case you guys, not many people were able to solve it, I hope the next exercise will have more individuals that are able to solve this problem and then give us optimal solutions into the our problems, or in solving our problems. So this will be it for this tutorial or this video. I will see you guys in the next tutorial, where, and also this is this week. So this week I'm not going to be uploading videos every day, since, as I said, I have things going on. So I'll upload at most 3 videos this week. So just sit, relax, and then you take the course at a slow pace. See you guys in the next one.